Hello friends, welcome to the VLC design course. So today we are going to realize a 7 segment display decoder on the FPGA board. So in previous lecture we have written a complete VHDL code for we can say binary to or BCD to 7 segment decoder conversion. So where we converted a 4-bit binary input, and that particular binary input value represented on the 7 segment display. So for example, if we have binary input like 0 0 0 0, it should represent on 7 segment a 0 display output. So for that particular implementation we have written a VHDL code, we have simulated it, synthesized it and generated a bit file. So in today's lecture we are going to use that bit file, program it on the FPGA, and we are going to verify it on the development platform. So let us start. So in this I am just giving a overview how we are going to validate the decoder logic. So this is our 7 segment. Yes, these all 7 segments are connected as a multiplexing. So we have used a controller logic so that only one 7 segment will be on. So this control logic is connected to the J6 header of the J6 header is connected to the control of the 7 segment displays, and J7 header is nothing but our 7 segment inputs like segment A, B, C, D, E, F and G, and these the J7 header we are going to connect the P6 header of the FPGA. Try to understand, this J7 header I am going to connect to the P6 header, because according to that only we have written a we have created a UCF file. Similarly, J6 header we are going to connect to the P2 header, and for the BCD input the switches we are going to use it, and that is connected to the P1 header. So our implementation flow is like this. We are going to give a 4-bit binary input using these switches, right? Using these switches, then this input is going to the P1 header, then P1 headers is connected to the FPGA BCD input signal. Then inside the FPGA, whatever the VHDL code we have written, that functionality will happen. It will generate a BCD to 7 segment decoder logic, and then a respective value or display value will be displayed on this 7 segment display. So we are going to give the input through switches, and we are expecting a particular display value on this 7 segment display. Okay. So let us begin to implement or to program our yesterday's or in previous lectures generated bit file. Okay. So whatever in earlier lecture we have generated bit file, that bit file we have to call program FPGA and validate it. So open the programmer, FPGA programmer, open the file. So okay, where we have written this is SSD, then this is BCD to SSD dot bit file, then we have to open it and just say the program. Okay. So let us move to the development board. Okay. So our FPGA is programmed. You can observe it here. The blue LED is glowing, so we can easily observe it here. Now we have to verify the functionality. So as I said, these switches we are going to use binary input. So this switch 1, 2, 3 and 4 are the binary input. So this has a MSB bit, this has a LSB bit. So we can force values from 0, 1, 2, 3, 4, 5, 6 up to F. Okay, up to 15, that is F. So we are going to display this respective input value on this 7 segment display. Now I think it may not be clearly visible, so I will try to clear it. No, sorry. Okay, I'm trying to little bit clear through the camera, but I don't think so. Okay, let us try. Let us say input 1. It's very difficult to exactly show you. Let me try some different way. Now is it visible? No, it's completely glowing. What to do? I have very okay. When it is 0 0 1, it's showing the binary 7 segment display 1. Yeah, so somehow I try to manage the that reflection of 7 segment display. So I have kept my mobile phone on top of the 7 segment display. I think now it's much better visibility. So as I said, this switches I am using as the 4-bit input. This switches I am going to use as a 4-bit input, as a binary input or a BCD input, and particularly, so here you can observe the 7 segment display out. 7 segment display out. So when input is 0 0 0, it is showing SSD 0. When it is 0 0 1, 0 0 0 1, it represent SSD 0. Sorry. Again some problem. Okay, 0 0 1, then 0 0 1 0, it is 2, right? Then 1 1 3, I will just finish it off fastly. 4 5 6 7 8 9, then A, B, C, then D and the F. So like this we can implement a BCD to 7 segment display, BCD to 7 segment display using the 7 segment display as a output device. So I think you have understood this realization. Sorry for the disturbance, because I could not able to show you the clear realization, but somehow I shown you how the 7 segment display looks like. Once you do by yourself and try to implement on the development board, definitely it is much more understanding, and you can do by yourself also. So my recommendation, implement a VHDL code, write a VHDL code, implement by yourself, and try to implement on this development platform so you can understand in a better way. Thank you. Keep watching the videos.